Okay, welcome back. We're going to finish up the last few clickers from this chapter on free fall. So we had this question that said, I drop a 2 kilogram ball from rest. From rest means at zero initial velocity. How fast is it going half a second later? And the answer was about 5 meters per second, because every second something falls, the downward velocity increases by 10 meters per second. So half a second would be half of that, and that would be 5 meters per second, since it's a constant acceleration. It's a uniform acceleration. Okay, so let's go on to the next one. Now, this time, I throw a 2 kilogram ball downwards at a speed of 10 meters per second. So I'm throwing the ball off the top of a tall building, let's say, and it leaves my hand with an initial velocity of 10 meters per second. Okay, how fast is it going 0.5 seconds later, half a second later? Is it going 20 meters per second, 15 meters per second, 10 meters per second, 5 meters per second, or 0? Okay, pause the recording, please, and make your selection. Alrighty, 3, 2, 1. And the popular answer and the correct answer was B, about 15 meters per second. That's because the ball is initially going downward at 10 meters per second, it's going to gain another 5 meters per second of speed. Remember, in the last question, we said that it gains 5 meters per second of speed for every half a second. Well, it still gains that 5 meters per second of speed, but now you have to add it on to the 10 meters per second. So that is why we have 15 meters per second. Okay, so the change in velocity is still 5 meters per second downward, but now you have to add it to the initial velocity. All right, I throw a 2 kilogram ball up in the air. If there is no air resistance, what is the net force acting on the ball as it rises? Okay, is it A, 0? Is it B, 10 newtons upward? Is it C, 10 newtons downward? Is it D, 20 newtons upward? Is it E, 20 newtons downward? Or is it F, none of the above? Okay, pause the video and make your selection. Alrighty, going once, going twice, going 3 times. And the correct answer again is 10 newtons downward, or I'm sorry, 20 newtons downward, because it's 2 times 10 newtons downward. This seems an awful lot like a question at the beginning of the previous video, but it may have just been that I throw the ball up in the air instead of dropping it. It doesn't matter if I drop it or throw it up or throw it down. The force is still the same. It's the mass times the gravitational field strength. Okay. Alrighty, next question. I throw a 2 kilogram ball up in the air. If there's no air resistance, what is the net force acting on the ball at the moment it reaches the top of its motion? Okay, so I throw it up in the air. At that instant it reaches the top of its motion, what is the net force? Is it A, 0? Is it B, 10 newtons upward? Is it C, 10 newtons downward? Is it 20 newtons upward? Is it 20 newtons downward? Or none of the above? Okay, pause the video, read the selections carefully, and make your selection. Alrighty, 3, 2, 1. This is interesting. Okay, as I expected, a lot of people said 0. Okay, and as I said in the middle of the previous clicker video, at the tippy top of a flight, it does not mean that the object is stationary. Okay, it does not mean that there's no force or no change in velocity, because the moment before it's at 0 meters per second, it's going upward at a slight velocity. The moment afterwards, it's going down at a slight velocity. So the velocity is changing. If the velocity is changing, that means there needs to be a net force. So if the net force was 0, ask yourself, at the top of its flight and the net force is 0, what's the ball going to be doing 1 second later, or 2 seconds later, or 3 seconds later? It's just going to be floating there in midair. And you know from experience that that does not happen. When you throw a ball upward, what goes up must come down. So you know that a ball doesn't stay at the top of its flight. So the only possible answer then is E, 20 newtons downward, because that's the mass times the field strength, 10 newtons per kilogram. Okay, so the gravitational force is still the only force acting on the ball. It's the only force acting on the way up. It's the only force acting at the tippy top of its flight, and it's the only force acting on the way down. I throw a 2-kilogram ball up in the air. What a surprise. Suppose it has a speed of 15 meters per second at the moment it leaves my hand. How fast is it going 2 seconds later? Okay, I'm throwing it up in the air at 15 meters per second. So the velocity is 15 meters per second upward. How fast is it going 2 seconds later? About 20 meters per second, 15 meters per second, 10 meters per second, 5 meters per second, or 0. Okay, pause the video. Take a good long time to think about this one if you need to, and then answer the question and proceed. Okay, 3, 2, 1. And as I suspected, there's a smattering of answers all over the place. Okay. So the correct answer is D. So the most popular answer was correct. Here's the thing. I'm throwing the ball upward at 15 meters per second. Okay. How much does the velocity change in 2 seconds? Okay. So the velocity changes every second. It changes by 10 meters per second. So 2 seconds later, it's going to change by 20 meters per second downward. Okay. So those of you who answered 20 meters per second, that's the correct answer for a different question. Okay, that's a correct answer for how much was the change in velocity. Okay, the change in velocity was 20 meters per second. Okay. Those of you who answered 15 meters per second, I don't know. I don't know where that came from. So, yeah, I don't know. Okay. C, nobody answered C, but D was the correct answer because it's going up at 15, but then it changes by 20 downward. So the difference between those two, 15 up and 20 down, is an extra 5 meters per second down. So in those 2 seconds, it has lost its upward speed and has gained 5 meters per second downward. Okay, so the change in velocity is 20 meters per second downward. All right, next one. In the previous question, the ball's mass was 2 kilograms. Does the answer depend on its mass? In other words, if you threw a 1.465 kilogram ball instead, would the answer be any different? A, yes, the smaller mass will respond more quickly to the force and experience a greater change of velocity. Or B, yes, the force on a smaller mass is less, and so it will experience a smaller change of velocity. Or C, no, the answer will not be different at all. Okay, pause the video and make your selection. And please make sure to do these pauses. Don't just go on to the answer, because without you thinking about what these answers possibly are, you really aren't learning anything just by finding out what the right answers are. You really have to think about these things and try to select your idea of what the right answer is. Okay, so pause the video and make your selection. Alrighty, 3, 2, 1. And it looks like everybody from last year's class got C correct. That's pretty good. Okay. The mass of an object, all bodies near the surface of the Earth fall with the same acceleration, the same change in velocity for the amount of time that they fall. Okay, so it doesn't matter if the mass is heavier. Heavier objects do not move faster or do not fall faster than lighter objects. Now that might not make much sense because in the first few chapters we were saying that the more massive objects are more sluggish. So let's say, for example, we have a 2 kilogram ball, and let's just round this off and say this is a 1 kilogram ball. Let's forget about this 0.465, which is kind of ridiculous. That means that the 2 kilogram ball is more sluggish. It's twice as sluggish as the 1 kilogram ball. But the thing about the gravitational field strength is that the force of gravity depends on the mass directly. So that means that the 2 kilogram ball is automatically being pulled to the Earth with twice the force. So even though it's twice as sluggish, it's being pulled with automatically twice the force because it has twice the weight. And because of that, it falls with exactly the same change in velocity as the 1 kilogram ball. So a 2 kilogram mass has 20 newtons of force pulling on it. A 1 kilogram mass would only have 10 newtons of force pulling on it. And so that's why they end up falling to Earth, speeding up toward the ground at the same rate. Hope that makes sense for you. Okay, let's go on to the next one. I drop a 0.453 kilogram ball. How fast is it going half a second later? 20 meters per second, 15, 10, or 5 meters per second, or 0. Okay, pause your video, please, and make your selection. This shouldn't take too long, hopefully. Alrighty, let's see the answers in 3, 2, 1. And the most popular answer is the correct one. Okay, D, about 5 meters per second. So again, it does not depend on the mass. Every object that falls speeds up at 10 meters per second as it falls. Now I throw this ball downwards. Okay, I throw it downwards with a speed of 10 meters per second as it leaves my hand. How fast is it going 0.5 seconds later? Okay. If you think this looks like a question we had earlier, you are correct. Pause the video and make your selection. Alrighty, 3, 2, 1, and the answer would be 15 meters per second because it speeds up by half of 10 meters per second downward. It speeds up by 5 meters per second. On the way down, it already is going down initially, and so you add the 10 to the 5, and 15 meters per second is the change in velocity, or rather, change in velocity is 10 meters per second each second, so the change would be 5 meters per second, which you add to the 10 to make 15. Okay, next one. This time I throw it up in the air. Suppose it has a speed of 15 meters per second the moment it leaves my hand. How fast is it going 2 seconds later? Again, very similar to one we've already had. Pause the video and make your selection. Okay, 3, 2, 1, and 5 meters per second. Again, basically the change in velocity in 2 seconds is 20 meters per second down. It started out by going 15 meters per second up, so therefore the difference is 5 meters per second downward. That's the excess speed. I drop a 2 kilogram ball from rest. How fast is it going when it hits the ground? Is it going 9.8 meters per second, 4.9 meters per second, or C, it depends on how high above the floor it was dropped. Okay, pause your video and make your selection. All right, let's see. 3, 2, 1. Oh, we don't have any answers for this one. Okay, I don't know why. I think they got erased from last year. But the answer is C. Depends on how high above the floor it was. Okay, if you drop it off a low chair, it's going to hit the floor sooner, and therefore it's not going to have as much time to speed up. If you drop it off the top of a building, it's going to have more time to speed up, and therefore it's going to hit the floor with a much larger speed. Okay. A ball is dropped from rest. Assuming gravitational field strength of 10 newtons per kilogram, what's the ball's average velocity during the first 10 seconds of its fall? This is a very important one. Okay. 0, 5 meters per second, 10 meters per second, 50 meters per second, or 100 meters per second downward. Pause the video and give your answer. All right. The answer is 50 meters per second. Think about it. It starts at 0. After 10 seconds, it speeds up to 10 times 10, or 100 meters per second. The average is going to be, you split the difference between those two. It's 100 plus 0 divided by 2, which is 50. Okay, we are out of time, so that is the end of the clickers for this chapter. Take care.